So, all of the exams have been graded, which is pretty sweet. All you guys should have those exams up on Canvas in terms of the grades. So if anybody does have any questions about any comments that I made, any of your scores, anything like that, uh, definitely let me know. We can talk about it kind of near the end, just so that we can get any of that stuff settled if there's any confusion about scores or anything. And also, if you guys want, I can post like the parts that I made. So like directly what I made. If that's of interest to any of you guys, I can post exactly how I made those parts, um, and then you guys can kind of take a look at them and maybe gather something from it, if anything. Um, but we can probably get started here in just a sec anyway. So pretty cool. Today's going to be pretty fun, and I know some of you might not think that, but some of this is actually going to be pretty cool stuff. So today we're going to go through creating assemblies and using the Solidworks Toolbox. So if we are just taking a look at the PowerPoint for a little bit, assemblies are pretty cool. So an assembly is just going to be a way that we can take multiple parts and put them together in some sort of logical manner. Um, Parts are referred to in an assembly as components, and the specific way that we like to put these parts together is called mating. So we mate parts together, which creates some sort of relationship between parts. So generally speaking, um, you do want to have a pretty good understanding of the parts that you're using. Uh, so if you're just kind of making parts on the fly, it can be a little bit tricky, but nicely enough, just kind of like how, and some of you might know this if you've kind of played around with the drawing manager, but for anybody that hasn't played around with the drawing manager at all, uh, you can have several parts or components open at one time, and then uh, you can also have the assembly that is kind of grabbing all of those parts as well. So if you make any adjustments to an individual part, so long as that part is saved and within the assembly that you are using, you can kind of make little fine adjustments as you go along. So it is pretty nice in that aspect. So you might have several files open at once. That's kind of the slight pain about using assemblies, but it's a good way of being able to kind of play with several parts at once and then see what happens uh, when you make that adjustment, how it translates from the part to the individual component within SolidWorks. So just getting started, this entire time, we've been just hitting that far left button, the parts button, but now we're going to actually start working on assemblies. So assemblies is going to be the middle option. So for something like that, we're just going to click the center button that we have when we create some new, new component or new kind of document, I guess you could say, within SolidWorks. So I'm still just playing around with the PowerPoint right now, and then I'll go or kind of show more of it within SolidWorks. And also, I know I mentioned it, or at least I believe I mentioned it, all of the demos that I'm going to do today, including both the one that is in this PowerPoint and the ones that I want to do when the PowerPoint is finished, all of those are currently on Canvas. They're in the lecture folder, so it should be just like something to do with like a assembly. So they should be like directly below the lecture. So it should be two zip files that are in there right now. Um, Definitely take a look at those, download those if you guys want to kind of follow along once we get into some more of the like advanced assemblies that we'll be talking about kind of after the PowerPoint is through. But for the time being, we're just going to focus on uh, kind of the initial demo, which kind of talks about more of the general basic features. So if I go back over to SolidWorks, we can kind of get started on some of this stuff. So I'm going to open up a new document, and I'm going to hit Assembly. And the first thing that you'll notice, or rather, there's a couple things that you'll notice. First and foremost, we have a lot of different stuff here at the top. So now this primary tab is labeled Assembly. And this is going to be where a bulk of the stuff that you're going to work with will reside. But it'll also open up a directory. Now, the idea here is that you want to open several parts for your assembly. I'm actually going to get out of that one, and I can't remember the specific folder. I think it was this one. Oh, I was just doing the basic stuff, yeah. So the three parts that I just have out here normally are this guide, if you can kind of see it. We have a guide, a plate, and a rod. And now I want all of these things in my assembly. There's several ways that you can sort of do this, but one manner is you can just control left click all of your parts. And what that will do is that the second I hit open, it will put all those parts, it'll populate this open documents drop down. And then it'll just one by one allow me to insert these parts within the graphics menu. So I'm just going to do that, but you can add things one at a time. And in fact, I'm actually just going to do that just so you guys can kind of see how to insert multiple components. So I just want to open this guide first and foremost. And this is going to kind of be like our base part. So I can hit OK with the guide open there. It shows me this part. So if I kind of middle click, I'm able to move it around. I don't want to left click quite yet because I want to show you guys just the part, and I want to be able to show you some other things that you can do with it. So not only do we see some stuff here on the left side of our screen, we see that it's trying to open up the guide, but we can also see this little thing down here at the bottom. So that's pretty nice. It allows us to rotate that figure in different directions. So you might have to kind of squint a little bit if you're looking at my stream, but if you do have SolidWorks open, those buttons are going to represent what axis it will rotate around. So currently it's saying I want to do a 90-degree rotation about either the x-axis, the y-axis, or the z-axis. So if I hit X, it's going to rotate it in this kind of manner. If you guys were able to see my mouse. So this kind of orientation that it just created should come as no surprise. And I can just hit it a couple more times to get back, come on, to get back to its original orientation right there. Now I'm going to left click just so I can insert that component, just so that I have it ready. Now, I might want to add other components to this. I mean, all I have here is I just have a single part that doesn't really do a whole lot for me. It kind of defeats the purpose of actually creating an assembly where we want to have multiple parts open at once. So what I'm going to do is I'm actually going to use the Insert Component button. And I mean, as you might expect, this allows us to add more components to our geometry here, or rather to our assembly here, and it'll typically open up the exact same directory. So now I'm actually just going to open both of these up. I'm going to hit Control and left click as I select both of those guys, and then I'm just going to hit OK. So now it's letting me insert both of these extra parts here, and I'm not really going to orient them correctly, even though I know the direction that they should be oriented in, because that would totally defeat the purpose of talking about the ability to mate parts. So I'm just going to left click there, and I'm going to left click there. So now I have three parts here in this graphics menu. And if we kind of take a look at just our PowerPoint for just a second, really all that's going on now is we might see some new stuff. So, I mean, kind of, as I say in the PowerPoint, sure, we have a bunch of parts that are just hanging out, not really doing a whole lot, but let's talk about maybe certain things that we can identify with regard to the parts, and what else we can really do with those parts. So the first thing that I want to kind of point out is that if you're looking on the left side of the screen, especially if you're following along kind of with your own SolidWorks open, you'll see some symbols that come like in front of the names of your parts. Now, one of these, unfortunately, you might be fairly familiar with, and it's that minus sign. And yes, it does mean the exact same thing. So if it has a negative sign kind of in front of whatever the part is, that's going to designate that your part is undefined. And not specifically the part itself. It's saying that for the assembly, it is underdefined. So what that means in terms of an assembly means something a little bit different than how it does in terms of just your typical SolidWorks part. So in the case of an assembly, what it means for it to be underdefined is it means that it still can, its motion is limited, or rather its motion is not limited. So currently, right now, these parts can just move around. They have absolutely no order to them. They're in total space. They don't really do a whole lot. However, this part here, and you will notice that it was the first one that I did put in, I can't move it at all. I'm left clicking and I'm trying to drag and it won't do anything for me. And this one has an F next to it. That F stands for fixed. So anything that is fixed means that it will not move. All of its ability to move in any orientation is completely fixed. It will not move at all. These, however, are not fixed. These have complete motion. They're not restricted in any sense, which is not particularly what we want. We want to be able to do something about that. So first and foremost, we might want to say to ourselves, okay, well, what if I screwed up? Maybe I added the plate first or the rod first. How can I adjust this such that the correct thing is fixed? So there's a couple different ways. One way is that if you actually mouse over it in the tree, if you just right click on it, then you should see kind of near the top, it's maybe about like 40% down on the list, you'll see something that is the opposite of what that part currently is. So if you have a fixed part, you should see the word float. If you have, and this just can show you that you can also right click on the part itself, if you right click on a float part, which essentially means that it is not fixed in any way, it has complete ability to move as it pleases, you can fix those components as you will. So there are ways, thankfully, to be able to switch things between one manner or another. And I say it in the PowerPoint, but basically fixed is implying that it has, or rather that all of its degrees of freedom are, how should I put it? It really has none. Or rather, all of those degrees of freedom are limited or locked in some manner or another. And I will ask about degrees of freedom in a little bit, so hopefully you guys, this isn't the first time you've heard of it, hopefully, but if it is, then we'll kind of discuss that a little bit. So moving on a little bit, and I kind of explained float a bit, which basically is just saying that it has the maximum amount of degrees of freedom. Quick question for anybody that knows, and I know that we have a lot of people here, but does anybody here know how many standard or general degrees of freedom that we have for a given geometry or part? Really anything. Anybody at all?
Six?
Yep, we have 6 degrees of freedom, and it's broken up into 2 groups. So we have translational degrees of freedom and we have rotational. So that is to say, and if I kind of go back to SolidWorks a little bit, that's to say that I can move it in the x-axis, I can move it in the y-axis, and I can move it in the z-axis. And then I guess if I could do this with just being able to left click on things, oh, I can just right click. I totally learned that. I can right click on parts and I can rotate it about the Z, I can rotate it about the Y, kind of is not very specific, and I can rotate it about the X. So those are 6 degrees of freedom. Generally speaking, if a part is fully defined, all of those constraints are met in some manner or another. That's not to say that it's totally incapable of moving, but it is limited in some manner or another. If you guys have taken like I feel like maybe most of you have taken or are taking calculus, you can kind of think of it as like almost, or maybe some of you guys are taking like differential equations possibly. If not, that's okay, but you can think of it kind of like boundary conditions almost. And to explain that, boundary conditions are really just saying, hey, we know how this function might be defined at the beginning, and maybe we don't know what the function is defined at, say, the end, but we know some other reference point. So we have two reference points. I guess that's one way that you can kind of uh, assume it to be motion, or rather assume motion to be limited in some manner or another. So what we can do is we can manipulate components. So you see that just using your mouse and left clicking or right clicking isn't always the most efficient way of doing it. Sometimes we might need to be a little bit better with how we move our parts around or kind of create motion. So what we're actually going to use here is we can use a move component tool. So move component is fairly self-explanatory. Things are going to be restricted to either movement or rotation. So really, we can just click on move component, and what's nice about it is that we can move several things around at once. So it'll kind of highlight a surface, and then it'll say, okay, I get it. This is what you want. This is what you want to be moving here. So there's a handful of different options here. Free drag is kind of what you expect. It really has no kind of order to it or any sort of standard behavior. Not what I wanted, but that's okay. We have along the assembly's global coordinates, so that means that if I move it, or you kind of need to be a little bit specific about this, but what's nice is that once you kind of get it moving in one of your cardinal directions, it will only move in that direction. So you saw me moving it in the X direction. If I kind of turn my interface a little bit more such that maybe I want it to move in the Z direction, it moves quite nicely. I can do the exact same thing with the Y direction as well. So, and I mean, a lot of these are different options here. So along an entity here, I assume you would be selecting some other reference point, and it would be moving kind of in relation to that reference. So it can't really, has to move in some sort of logical manner. So it can't really move up and down if I'm selecting the guide. It's kind of considering the guide to be almost like a surface. We have by some delta x and y values, so if we need very precise measurements, we can do that as well. Or if we know specific information about the coordinate that we would like this this part to be in, we can do that as well. I am making an assumption here, but I would assume that the XYZ position is going to be based upon the center of mass of our shape, or rather something akin to the centroid. If we want to do rotate, we just have to hit this rotation drop-down menu, and it has fewer options, but they're all very similar. We can do it along an entity, or if we know an exact rotation that we might want to turn it in, we can just set it to that. So maybe I want to turn this in 27 degrees along the x-axis, so knowing this, it should rotate either clockwise or counterclockwise, kind of from my view. I would assume counterclockwise? Okay, I think it's more about the actual axis that we're dealing with. So it's rotating about the global axis, but that still was counterclockwise. Rule of thumb, we generally take counterclockwise to be a positive direction. There's also some really cool features as well. So as you've been seeing, this was just the standard drag. However, and I want to do a move, but I want to try out collision detection. So warning for anybody who might not be expecting it, this will play a noise, but it's kind of cool because basically you can move stuff around and maybe you want to get things in position and all of a sudden it hits it. So it's referencing, and even when I hit it, I can't move it any further. So it's just going to totally stop at whatever object it is colliding with. I believe it will even do the exact same thing for other parts, despite them being floating parts as well. Generally, I believe when you first start off, this option is not selected, so you kind of will want to have the stop at collision uh, check mark selected, just so that it'll be at least more defined. You'll say, oh, can't continue any further. Physical dynamics is pretty funky. I don't play with this that much. This is kind of like those really silly physics games where you really can't do anything you want it to do. So I would, well, that's kind of nice. It actually gives you or shows you where the center of mass is. So that is a benefit if you're kind of trying to figure out maybe where specific things might be, or if you're just dragging this around, but it is a lot harder to get things in a precise location if you're using this, just because it's going to start moving around other parts as well, and that might not always be what we want it to do. You can adjust the sensitivity, but I would say your two more common options are either going to be the standard drag, or if you're ever in doubt, collision detection is pretty cool as well. So that's just a little bit about how to move the points themselves, or rather how to move the parts that we have in our assembly. But let's talk about some other stuff now. So if we're kind of going back to the PowerPoint for just a moment, we talked about manipulating components. Now we're going to talk about mating components. So this is kind of where we left off just a little bit ago. And as I asked that question earlier, there are 6 standard degrees of freedom, and these are the 3 translational and 3 rotational. So mating components really just means that we are going to put them together in some sort of logical way. And the nice thing about mating components is that it makes it such that we slowly create more definition to our assembly. We get to a point more so further and further where we at least have some sort of really cohesive assembly coming together here. So a couple rules of thumb. Uh, First thing, I'll kind of go over that bottom picture there along with the tips. So first things first, use a common mating reference. If I am going to mate parts with regard to what I have currently in SolidWorks, I'm generally going to want to use the thing that is fixed to be that common reference. That's not to say that you can't mate other parts together. However, you'll see some, I guess you could say, unfortunate behavior depending on how you are mating your parts. So you want to be a little bit careful. And that's kind of why it leads into some of these other things which I mentioned, which means like don't create mating loops. So what that means is that try not to create any sort of circular, and kind of ties into the next one, any sort of circular dependencies, where the motion of one part is dependent upon the motion of another part, where that first part is not already very rigidly defined or fixed in some manner. We start getting into some hairy territory if we try to do stuff like that. And sometimes, like I said, parts might not behave the way we want them to. And also just try not to over-define using mates. And this is something that will kind of come with time and practice, just like how a lot of you guys kind of maybe figured out the hard way on over-defining parts when we were just creating parts in general. Um, so kind of a good little example of mating parts here is that you can see this picture here kind of on the top right, where it's basically saying here we're going to mate together this part that kind of looks like, I guess it kind of looks like almost like a boxy camera or whatever, something like that, or container, what have you, I don't know. But basically, it's creating an edge mate, which you can do. Basically, the most standard kind of mate that you're going to have, very similar to what we had when we were creating parts, is a coincident mate. And coincident mates just mean that if you have, say, 2 surfaces that are being coincident mated together, that means that they're kind of glued together. We know that there's not supposed to be any motion. So in doing that, it is restricting some of our degrees of freedom. However, and just like how the picture shows there as well, technically speaking, that part, the gray one, or even the blue one, I suppose it depends on which one is fixed, if either are, they can move kind of almost like in a shear manner together, or rather from one another. Additionally, one of them or both of them can rotate around that common edge, which essentially forms an axis. So we sometimes want to be fairly careful on how we're creating these mates. Sometimes we might create a mate but it actually doesn't restrict motion the way we wanted it to, which might require us to create additional mates, which is not a bad thing. Generally speaking, we are going to have to create several mates at a time, sometimes a ton. Um, so let's see what else. So just covering, so now we've talked about how to actually make these parts together, or rather how to do it. So let's actually kind of take a look at the menu, and I guess maybe before I do that, I can just kind of do a little precursor on what we should expect to see. So in the command bar, we're going to end up seeing uh, the option to, or rather in the assembly tab, we can see the mate option, which kind of looks like a paperclip. So we have three general types of mates. And some of these you will generally be using less than others. Some of these you're going to be using a ton. Standard mates occur very frequently. Advanced mates are pretty cool, and mechanical mates can be used in some niche circumstances as well. The demos later tonight are going to cover using advanced mates and mechanical mates. For now, we're primarily going to just be talking about standard mates. The video that I also have provided, there's a little hyperlink there, so just control click that and open it up and watch it later at your guys' leisure. I highly, highly, highly recommend you watch the video. The dude does a very excellent job at actually describing when to use the mates, how to use the mates. Um, just a very good overview of like 95% of the mates that we have here, aside from the standard mates. A lot of those ones based upon kind of nomenclature that we've already been using should be fairly intuitive. So things that are coincident are going to be next to each other. Things that are parallel, whatever surfaces or edges you're dealing with should never intersect in any sort of manner. So they're always going to be parallel, perpendicular, tangent surfaces, so tangency is very good, and also concentric. Concentric is also going to be very helpful for us. The bottom two that you see there, kind of the one with like the two arrows in opposite directions, and the ones where it's kind of an angle, kind of maybe perhaps self-explanatory. The very first one is going to be designating a rigid distance, and the other one is going to be designating a rigid angle. So if two things need to be at a specific angle and they cannot move from that angle, rare, but it can happen in certain circumstances, those will be certain things that you want to go to. Additionally, you'll see right below that is something called mate alignment. You are also going to be wanting to use this very often, and you'll see me using it quite frequently as well when I start going through this demo. Okay, so if we're looking back at our part now, and I'm going to stop talking off the PowerPoint because I'd rather just kind of play with some of this stuff now. So let's just focus on the guide and the rod first. So as you might expect, this rod is going to be able to fit into this this hole here that I was able to create for this guide. So one thing that I want to do is I want to make sure that it aligns properly. But the nice thing is that I don't need to explicitly make sure that before I make these components together, it's in the correct manner. So what I'm going to do first is I'm going to hit the mate button. And then I want to make sure that, and it kind of depends. It depends on what you're doing. Generally speaking, unless you really, really know what you're going to do with certain parts, I would recommend that you select the specific mate first. Generally speaking, flat surfaces are going to be a coincident or parallel mate to each other if you select those surfaces first. Circular surfaces or cylindrical surfaces generally will end up being concentric. As you might expect, things that are like a line and a circular surface will typically be tangent to each other. So just kind of understanding and maybe playing around with this stuff. I know I've harped on it many, 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 many times, and hopefully this will be no exception here when we're playing with assemblies. So I'm going to mate together this hole and the rod that's here. So I could, if I want to, I could just select both of them. I don't need to control select, but you can if you want to, but I'm just going to left click on the inside of the hole. What's nice is that it kind of shows me a hologram of it, gives me an idea of what I'm actually working with here. Then I'm just going to click on the circular surface of that there. Perfect. So what it did there, it automatically aligned these these geometries together. And you'll note I didn't click on a specific mate, but it already said, hey, concentric, right? Is that what you're after? Yeah, that is what we're actually after in a case like this. Sometimes, and it can be a point of struggle from time to time, it might try to mate certain things together, and you're just like, no, no, that's not what I asked for. So you might have to kind of give it a little bit of finesse sometimes. So we always want to make sure that we are hitting OK on our mate. And what's nice is that when we do that, it keeps the menu open. Generally speaking, it's going to say, hey, you're going to want to assign more mates. Is that correct? And I mean, if it's not, we can just close out a menu. And I kind of do want to do that first, just to be able to show you guys something. So as you can see right here, even though I constrain the rod to that cylinder, to that hole that was in the guide, it still can move. And in fact, it can move in several ways. You can see if I'm very kind of fine with the measurement here, it has a rotational degree of freedom, and it also has a single translational degree of freedom. So pretty sweet. I was able to restrict 4 of the 6 total degrees of freedom, but I wasn't able to get everything done. So we can still work on that. So another thing is, I'm going to make sure that I'm not selecting anything. I'm going to hit mate again. And now I'm going to make sure that these surfaces, and this time I'm actually going to select the mate first. And before I do that, I'm going to turn this a little bit, and you'll see why. But you guys probably already expect or know what's going to happen here. So I'm going to hit parallel. And I want this surface right here to be parallel to this side of our guide that we have here. And lo and behold, it kind of flips that, or rotates the bar rather, such that it is in line or parallel to that face. And I'm going to hit OK. I can hit the check mark here, kind of in the graphics menu, or I can hit it up here, so we have lots of options. And I'm going to close out of it. So now I can't rotate this at all. You can see when I'm trying to rotate it, pulling up and down, it's only moving it along, what is that, the z-axis. So it's not doing things that I'm trying to get it to do, but thankfully it's doing things in the correct manner. I don't want it to move in that manner that is shown there. So another thing to note that is on the PowerPoint, but I'll just explain it here. Usually when you do click on certain surfaces, Solidworks and the mate assembly will typically recognize what mates are going to be allowed. So you see, maybe you noticed it, maybe you didn't, but I clicked on the top face of this surface here, of this guide, and you can see I can't choose a concentric mate anymore. Well, why is that? Well, I mean, if we're thinking about what concentric means, it means that we have two circles that have an identical center, or rather they start at the exact same center. It wouldn't make any sense whatsoever for us to be able to mate a surface or a face, something that is not circular, with virtually anything else. That would be more akin to something like tangency, or perhaps maybe something else that does have a flat surface to it. I would maybe want it to be parallel or perpendicular. Or maybe I want something to literally just be on top here, kind of glued to the surface, which would be like coincident. So I'm just going to exit out of that. So now, like we said, we can move this kind of back and forth. So can't really do a whole lot. It's fairly restricted, but that's okay. That's essentially what we want it to be. Now, so let's see. Let's see what else we can mate together here. So if we actually look at our tree, we've done a bit. We've done a little bit of stuff, but we haven't actually fully defined anything quite yet, which, depending on the application, it could be a bit problematic. So let's try to remedy that. Let's maybe try to make things a little bit more complicated here, which might not be ideal always, but that's okay. We can work with it. So you can see I'm rotating this a little bit. Now I want to play a bit more with this plate. So I know some of you are probably yelling at me already. I said we don't want to have kind of this nested structure of mates. However, sometimes and oftentimes it will be acceptable. So yes, we do generally speaking want to have a common reference or a common mate between all the other parts. So one thing kind of expanding out to several different parts, but this is okay. This is acceptable. we'll be able to kind of gauge why here very soon. So I'm going to make sure that that surface isn't selected, and then you can see that this does have kind of a bit more of a cutout here. So I'm going to not click on a specific mate. I'm just going to click that inner surface, and I'm going to mate it to this surface here as well. So y'all are probably thinking, well, that certainly doesn't look like what I expected it to do. So we got to play with this a little bit, because currently it's saying, hey, you want these to be coincident, right? And first and foremost, if I hit select on this, or if I hit OK on this, we would have parts that are already intersecting, that there's collision going on between them, and that's not necessarily what we want to do. So first and foremost, I'm going to play with this a little bit more. And I'm actually going to use this mate alignment thing that we use. So this is going to be pretty sweet once I hit it. So it mates it a little bit better, but we're still really not quite there. So I'm just going to hit OK on that, but actually now I want to make this surface, or rather this cylinder, coincident, or not coincident, but concentric with this hole, and that might make things a little bit better. So there we go. Now it's looking a bit more like what we actually want. And keep in mind, it's actually taking things into account. So I'll X out of that, and now you can see, well, now it can actually rotate pretty well. I say pretty well, but it's kind of a little bit rigid with how it rotates. But I can move this thing around. Well, you'll notice that this bar is also moving as well. So we don't really want that, but it's okay for now, for the time being. So what we're going to do is let's actually make sure that maybe this top surface isn't so kind of fumbling around. Right now, it currently has 1 degree and 2 degrees, very similar to how our bar was before. So let's limit this a little bit more. So I'm going to go back to mate, and I want this to just be flat. And I'm actually going to look at some other reference points here that are parallel. So I'm going to put these two parallel to each other. So you see it didn't really do a whole lot, but it did make sure that now it's aligned properly. If I close out of this, and unfortunately we can't move parts around really when we're in the mate menu, so that's why I have to close out of it every time. But now, when I'm moving this left and right, it doesn't move. It is perfectly rigid. However, as you just saw right there, I can just push this part right through. You're saying to yourself, that should not be the case. So we could probably say, okay, well, we probably want to do like that whole like collision detection thing, but that's not actually going to create a mate. All that's going to do is it might give us a little bit more information about maybe how to mate it in certain circumstances, but it might not actually designate things in a proper manner. So let's actually dip into some of the other mates that we have here. And I can't remember the measurements that I used. So we're going to use another specific mate in this case. So we're actually going to close out of the standard mates and we're going to go into advanced. So there's a lot of funny pictures here, but I'm mostly concerned with just a single one here. So kind of similar to how we had the distance mate. Kind of the advanced version of that, the evolved version of that, is a limit distance. So if I click on limit distance, this is going to open up some extra menus here. And these menus are telling me about how much I want to limit the distance. Think about this kind of like that example that I gave before. This is like your boundary conditions for your part, meaning I want this, or I want it such that this face can come in contact with this face. However, I don't want it to go through. I want it to hit that face and then stop right there. Similarly, I don't want it to just be able to hit the face and then just zoom right out, like be thrown right out. So I want to make sure that it doesn't do that as well. I want to be able to limit the maximum distance that it could go. So I think I might be making a slight oopsie according to my PowerPoint, but I'm in millimeters right now, which isn't too much of a big deal. So let me just switch over just so that everything is fine. In my PowerPoint, I believe I have it designated so that it can only move an inch. So let's actually do this first. I'm going to actually not select the limit distance first, and wouldn't recommend it. That's okay. So right now it's saying, hey, you want these to be smushed together, right? And it's like, only kind of. It's not exactly what I want you to do, but I see what you're trying to get at. But now I'm going to hit the limit distance. And you'll notice, kind of like what I said before, certain other options here are already nixed out. So it's already saying, nope, you can't do that. Even with that selection, you're not able to do it. And what I'm going to do is I'm going to focus primarily on these two symbols here, the one with kind of lines really close together and relatively speaking, further apart. So I'm going to make the bottom one be 0, meaning the minimum distance it can be between those two surfaces is 0, and I'm going to make the other one to be a single inch. Then I'm going to hit OK on this. I think I did. OK, there we go. Now I'm going to cross out, or get out of that menu. So now we're in a pretty good position. You can see we no longer have an underdefined structure here, assembly here. And no matter where I grab it, rather on the rod or on the guide, or rather the plate, I can only move this so far. I can smush them together, and they are, from what it looks like at the very least, not intersecting in any capacity, or I can pull them further apart, and they're most certainly not intersecting in any capacity. I have no idea if I included this in the PowerPoint at all, but I will show you guys this just because I believe it to be important. In the Evaluate tab, we see some new options as well. Probably one of the most handy ones, aside from the mass properties, which we are going to be using later, we're still using the idea of mass properties, is the interference detection. Now, as you might expect, interference just means that two parts are occupying the same space. So it's really just a very good way of being able to determine whether or not this part is in contact, or rather beyond contact with another part. So I'm going to push this all the way to the surface, just so that if anything is interfering, it would be able to figure it out. So it's saying that it wants just like this thing, but I can click all of these here and just say, hey, I want you to just designate everything that's in this right now. And then I'll hit calculate, and this will produce a noise as well. Oh god, that's terrible. I hope there's something that can turn that off, but regardless. But it's a good way, it's a very good tool, so I would recommend to use it at times where you think certain things might end up interfering with each other. We didn't really use this a whole lot, but this little stoplight thing sometimes means that uh, certain things need to be rebuilt. So it's good that if you ever see that symbol to just click it, and it'll typically readjust things as necessary. So we're in a pretty good spot right now. We've fully defined our assembly going forward here. So I mean, by and large, we're doing pretty good. So everything is fully defined, and what the heck do I talk about next? That's right, the toolbox. So actually, before I get into the toolbox, does anybody have any questions with regard to just general assembly stuff? Like I said earlier, we will be going over more of those advanced mates. They will be useful. I'm just glossing over them right now because I think assemblies are far easier when you see what those specific mates do, as opposed to me just blathering for 20 minutes about like the 15 different mates and then you guys quote unquote are masters at it. I don't expect that. So any questions with regard to the mates that we've talked about so far, or just assemblies in general?
That noise that you were talking about, the horrible one,
Yeah,
does that indicate interference or does that indicate lack of interference?
good question. So I think it shows up, I can't remember. I probably heard it about 50 times the other night when I was making a homework assignment for you guys, because there was some stuff that was interfering. If you'll see down here, in the results section, it says not calculated. Even if I hit not calculated, it says no interference. So rely on the results more so, or this results box more so than the noise. Just because that will indicate stuff. I think it makes a different noise if there is interference, but I don't remember. Honestly, super easy way to check. I will suppress the limit distance. I'll move this inward and hold on to your ears, guys. Okay, what did I just do? I hit. Okay, so it literally just makes the same noise, but it will highlight in red anything that is interfering. So it's super useful if you ever have stuff where you're just like, maybe certain things aren't behaving the way that they should behave, or maybe even if you just have a sneaking suspicion that maybe things are going to be uh, interfering with each other is a very good way of making sure that's or verifying that. So I would recommend always check or always use the interference detection to make sure that nothing is hitting each other or anything like that. Um, to Where do you initially begin to reference mate toolbar? Oh, yeah, so mates are just going to be in the assembly tab. So in the assembly tab, it should be the very first one. If you just click mate, that will open up the menu for it. There's probably other ways of doing it, but that's generally speaking how you're going to mate parts together. Um, okay, I think we're good to go on to the toolbox. So, the toolbox has a lot of stuff to it. Toolbox is really just generally a way for us to integrate in pre-built geometry into our assembly. These are things that by and large you could, but you're not going to want to create by yourself. It makes things a lot harder. It's going to add extra time. There's virtually no reason to do so. So what would this pre-built geometry be? It's not going to be something crazy. It's going to be kind of more so what you would expect in engineering, things that we use quite often. So things like bearings, screws, bolts, washers, a lot of those things. I know it's kind of silly that they have a toolbox for washers. Like it's a hollow cylinder, what more do you need? But in instances where you might need certain specific things, it can be quite helpful. So, the way that we get to our toolbox. So, it's going to be on the right hand side over here. Some of you might have noticed these tabs that are here. Uh, it is right on the design library. That's right. So it should be the third from the top. It kind of looks like some books that are like stacked one by one next to each other. So in the very top of the list should say Toolbox. So if you click on Toolbox, generally speaking, whenever you open up an assembly, if you haven't been using screws or anything like that already, it's going to say that it's not added. Simple, literally just hit add in now and it'll automatically populate. It's not some extra stuff that you need to download, excuse me, or anything like that. It's already integrated in within SolidWorks. I think what it does is it's just saying, hey, if you need it, sure, we can load it in, but if you not need it, there's no reason to bog the system down. That would be my assumption. So the toolbox has a lot to it. Not only that, you can create other libraries or other toolboxes. You can add new screws if you know very specific things about what you're trying to do. But by and large, we're just going to use a lot of the standard stuff. So I believe I say that we're going to want to go into the AISI inch, and let's grab a socket head screw. So that's going to be under bolts and screws, and then the socket head screws. So I am going to go over here. We're going to go to inch. You can see it has a drop down with many different locations with however they do their standard measurements, but we're going to go to bolts and screws. You can see over here they have pins, washers, retaining rings, O-rings, stuff to make your head spin with how many different things they actually have. And then because I keep forgetting, we want a socket head screw. So some of these occasionally may or may not be designated by the screw hole type, but we'll talk a little bit more about kind of how to determine which one to actually use. And I believe I said we would use a socket head cap screw. So it's going to be this one kind of at the top right. So super cool. We can literally just drag and drop this right into SolidWorks. So left click and drag it in. And I believe, in fact, I think this might already be correct on my side, but just to make sure, um, we want to set the measurements appropriately to have a 1/4 inch diameter and a length of 3/4 of an inch. So as you can see, mine is already designated to that, but you can either use this little drop down menu and select whichever one has a 1/4 inch. There's a few different ones, I believe. I think, where is it? Yeah, there's a 7 and a 12. I think that's designating the thread. Um, I'm not really that concerned about that. Some of the details in the drawings might be a little bit more specific. I'll try to make sure that those things are coherent. On the left-hand side, you'll see that we can have a size drop-down menu there as well, and we can also designate the length. So this length is going to be in inches, and this size diameter is also going to be in inches. What's also cool is that we can use ones with a simplified, where it's just totally smooth surface. You can give it a cosmetic thread, and probably my favorite, even though I don't really use it quite often, is you can use a realistic schematic thread. So this right here is pretty darn good if you're ever dealing with applications that really do deal with needing something to be precisely threaded appropriately. For now, and you can choose either cosmetic or simplified, I'll just do, I like cosmetic, but I'll just do simplified because it's shiny. Stupid reason, I know. And then we'll hit the check mark on it. So what that's already going to do is not only did it give us one, but it's allowing us to place more in the menu. And you can see I can actually place things in some appropriate manners. This is pretty cool. And the reason for that is because you can see that it's already kind of in the place that it, generally speaking, should be. And the reason for this is because it's actually just assigning mates already. So if I click on this, not only does it give me another screw that I can assign properly, but if I just hit escape and get out of this menu, you'll see here that there's certain things I can't do. I'm pulling over here, it is not coming out. It's only rotating, which means it already created not only a concentric to the hole, but a coincident as well to the surface. So sometimes that can help you, it can benefit. However, just keep in mind and just kind of remember, like how we were talking about before, this actually is underdefined right now. Both of these are, just based upon the fact that it does have that rotational degree of freedom. And technically speaking, I think that's rotating in like 2 degrees of freedom since it's at a slant. Not like that really matters. I'm not going to quiz you guys on that or anything. That would be kind of stupid. But it is something to just keep in mind. Sometimes kind of having an understanding of the degrees of freedom that are going on within your assembly can significantly help you to determine what's going on, or maybe why something isn't working the way that it is. So kind of like what I said, you can kind of grab like the side of the screw and just play around with it. You can see, hey, it gets to move, pretty sweet. I'm easily amused, and it'll just rotate however, but it won't be able to. You won't be able to pull it out. This one, however, has absolutely no restrictions to it. It's not locked in any manner. However, if we were to fully define this, or rather define it a whole lot better, I would want to make sure that this surface is concentric with that. So I'm going to left or control left click on both of those surfaces, hit mate, and it kind of does what it should. Aside from the one glaring issue of it being in the incorrect direction, but if I hit align, it does it mostly proper. So now it's not actually where it should be. However, I'll assign this mate, and I'm actually going to move it up a little bit more and then say, hey, you, go with you. Now if I hit OK, now we'll notice that it will be able to rotate, but I can't pull it out anymore. It's locked in place against that surface. So you might have noticed some other things that we already have here as well, but just to go through one of them, and kind of the primary one that I do want to talk about, is that just like how we have sketch patterns and feature patterns, we also have component patterns. So the first thing that I'm actually going to do is I'm going to get rid of this one. I don't want it anymore, just for the sake of demonstration. And I'm going to click on my socket head cap screw. I'm going to hit linear component pattern. So the thing to keep in mind here, and this kind of harkens back to what I said a bit earlier. Assemblies tend to rely on you knowing a lot of information about your parts. And the reason for that is because I know it's probably been like less than 24 hours since I made this assembly just on my own to make sure that it worked, but I can barely remember what the distance between these screw holes are. I think they're about a ½ inch. So having that understanding of using your parts and kind of understanding what's going on with your parts makes creating these assemblies a heck of a lot easier. So as you might expect, I want to populate all these holes that are here, and it's going to work out in a very similar fashion to how our feature pattern works. I want to make sure that we have 3 in this direction and 2 in the parallel direction to this face. So I'll click this, and it automatically jumped me down to that other one, so I'll kill two birds with one stone. Jeez, I can't speak tonight. And let's just kind of briefly assign the specific things that we want. We want it to go down 1 and definitely not that direction. That one's too far. And we want 3 in the other direction, definitely not that direction. And then let's kind of eyeball it. I believe I made these a ½ inch, and hopefully my memory isn't too terrible tonight. Bravo me, and then another ½ inch. And then when I hit OK, and we could do a pattern seed only if we wanted to make it such that it only went in the vertical direction and horizontal direction, but I want to populate every single one of them. So I'll hit both of those. And now it's already showing us, hey, these are 6 screws, right? Yeah, that's exactly what we want. So a cool thing that we actually know about this, or that we can do about this, is that since we patterned it, whatever happens to the original happens to all of them. You might already notice that all of these are in the exact orientation. And this is kind of cathartic. If I start moving it, all of them move in sync with one another. So I wouldn't say that this is a necessity to use linear patterns or to use patterns often, but I mean, for the sake of ease, you're definitely going to want to pull things in and then say, okay, I want something going like here, here, and here. After, like, you're not going to want to do stuff specific for every little one of them, or else it's just going to bog down your time, and it's going to make things just overall a drag to get through. Well, just like how we have linear patterns, we also have, as you can see, circular patterns and pattern driven and all these other things that I typically don't use. But mirror, we are no exception to using the mirror as well. So let's find out perhaps a plane to do this through. And unfortunately, I placed this in an inopportune location. So as you can see right here, that's our right plane, and I definitely don't want to reflect it over that plane, or else it's definitely not going to look right. I think if I did this, they're going to be way the heck over there. So let's not do something like that. Let's maybe be a little bit smarter about how we mirror our pattern. So I'm going to delete that mirror. Yes, there we go. Let's maybe figure out a good way that we can kind of create a plane here. So what I would probably do is I might do something like this. And there's tons of different ways that you can do this, but the first thing that came to mind is I would probably say this plate is right exactly along the plane of reflection that I want. So first things first, I'm going to say, okay, well, what is this distance? So I'm going to control left click on both of those, and it tells me in my bottom right hand corner that the normal distance between those two surfaces is 1 inch. Okay, cool. I'm going to use that to my advantage. And actually what I'm going to do instead, I want to use the guide. And I'm going to create a plane based upon the guide instead. And the reason I'm doing that is just to be safe. You're asking me, why the heck do I have to be safe about any of this right now? Well, the reason I say that is just because if I use or if I create a plane that is based upon this, something that can move, I don't really want any possible instances to impact the plane that could be created. The guide is fixed. which means I have absolutely no worry about this thing moving unless I make it float. So I'm just going to say, okay, cool. These sides are 4.5 from one another. If I go, oh, I don't even have to. In assembly, we also can create reference geometry. So I'm going to click that and hit plane. I want it based upon this side, and I want it to be 4.5 divided by 2. And not the correct direction, I want it right there. Looks pretty darn good. And I'll hit OK. It's a small plane, but it doesn't matter. It extends off into infinity. And just like what we want to pattern, or rather mirror, these features here. So I'm going to go in the little drop down just so I can see everything since this is taking up my feature tree. It asks me for a plane to mirror this across. I'm going to select the one that I just made, and I'm going to select the local pattern as the component. So now, and for whatever reason it's not showing a graphical image of it. I thought it usually did, but guess not. I'll hit OK, and now, just to be sure, because things can happen, sometimes you have an astronomically small non-zero number, and Solidworks will scream and shout and yell. I'm going to make sure that there's no interference here. So it does say that there is some interference right at that point. And actually, there's a whole bunch of it. And for whatever reason, it's probably because of that little curve that's there. And I would say for the time being, that's really not going to be an issue. It's more so about making sure that you're using kind of what's correctly being assigned. So we can't really do anything about that other than kind of playing with what we originally put here. Um, but I mean, just for the sake of understanding, I feel like you guys have a pretty good idea. And then you'll see that all of these move kind of just as how they did in the other case. You can see all of them moving in sync. Very exciting. Let's see, what else have I discussed? Um, okay, so patterns. So coordinate system. Okay. Um, yes. So we can also create new coordinate systems as well. And you might be asking, okay, well, what's the point of that? Like, why isn't the global coordinate system good enough? Or why would we want to use a different coordinate system as opposed to the one that we originally start with, or just the global? Well, occasionally things change based upon references. So, I mean, you could think about it as just everything must have some form of a reference to something else. So, things like the center of mass will change, or rather, let me rephrase that. The location of the center of mass will change depending upon where you are referencing it. I guess that's the best way that I can possibly phrase it. So if we're looking at the geometry here, I want to place a coordinate frame right on this tip. So on the opposite side of where the plate is, and I guess you could say if you're looking at the side opposite the plate, the left bottom hand corner. So I'm going to just pre-select that, but you don't have to. And I'm going to go to reference geometry. When I go to reference geometry, the third from the top option is creating a coordinate system. So I'm going to click on that. And then you'll notice a handful of other options. Not really too many, but just designating orientation. SolidWorks actually does a pretty darn good job at making sure that what directions you want things to be in, it's oriented in the correct manner. It's going to be kind of the correct orientation that you designate to it. So I don't know if I really did anything specific in the PowerPoint, so that's totally fine. This is much more self-explanatory. But if I want to, it's already placing the specific directions of the global coordinate system right there. But perhaps I want to adjust things a little bit. Maybe I want the X direction to be in the Y direction, and maybe I want it to be flipped. So now you can see that things are adjusted totally. Now you can see that pretty much everything here, at least in reference to, say, like our y-axis and our z-axis, everything is kind of negative to that direction. Or perhaps if I placed it over here with the same orientation, now all of the values would be, generally speaking, positive, at least with regard to the center of mass. So all of these are things to kind of take into account if you're ever creating a new coordinate system. For the time being, I'm going to leave those as is, and I'm going to replace this one more time just kind of on the global. In fact, I'm actually just going to reset it just so that it kind of does things in the way that I want it to. So now I have a new coordinate system, and I'm going to hit OK. You can see it here. It's saying that our x direction is along that axis. Our z direction is normal to the face of the guide, and the y direction is effectively the height. Now here's why this is important, because you're probably thinking, just like I said before, well, what the heck does this matter? We already have a global coordinate system. Well, if I go to mass properties, we'll see some other information. And this information is in reference to the center of mass specifically. So it's already kind of showing us where it is based upon this reference point right here. This, I'm fairly certain, is the center of mass where that coordinate system is inside of the shape. But it's telling us where that center of mass is. It's telling us that from, or based upon where this where our global coordinates is, um, the x center of mass is 3.32, the y is 1.55, and the z is 3.32. Now, what if we use our other coordinate system? Well, it's going to change. Not by much, but it did change a little bit. We can see now that it's 2.25, 1.22, and negative 1.04. So all of these things have some sort of impact on how the geometry is. Obviously, there's lots of other information, but we don't really need to be concerned with too much of it. I'm actually curious. I don't know this for sure, so 225, 122, negative 104. I don't actually know if I do that. Aha. So some of those things do matter. Certain orientations, certain things that might be limited but can move, you would need to rebuild it. So now you see things didn't adjust too much, but the z value did change. It did get a little bit more positive, and it probably changed for the default coordinate system as well. I can't for the life of me remember what it was before, but I think certain values here changed, albeit not very much. So now the last thing that I kind of wanted to discuss, and this relates to kind of further in the future when you guys might be either sending me your assemblies or sending other professors or coworkers or students, what have you, and it will be helpful later on when we kind of go into stuff regarding the final project. But being able to make sure that this is like a package, everything is here and everything is ready, because technically speaking, if all of these parts are not referenced in some manner or another, you can't use them. I mean, obviously stuff for the toolbox is fine, but if you have the guide, the rod, but you don't have the plate, and you're supposed to be making something like that, but maybe you were expected to be given the plate, it's going to throw errors at you. It's going to say, hey, where's this piece? If you're trying to open up an assembly that does already reference the piece. So generally speaking, we want to make sure that when we are grabbing these assemblies, everything is in one nice little package tied with a bow, yada yada. So in order to do that, we're going to use something called pack and go. If you go to File, kind of near-ish the bottom, you'll see something that looks like a folder with some blue files in it. If you hit pack and go, there's a couple different things here. We can include drawings, which we don't need to be concerned about right now, simulations, which is going to be super cool. Hopefully we get some time near the end of the semester to talk about that. But also toolbox components, so making sure that any sort of toolbox components, if they were used, are included as well. We can save things as either a just in a folder, so what that's going to do is it'll put all of the files in there, or you can basically select which ones you do and don't want into a specific folder of your designated location, or you can just create a zip file, which these are super cool. So I would like for you guys, generally speaking, when you are sending me files, to send things as a zip file, because what it's going to do is it's going to save me the trouble. I know I say that, but I hate saying stuff like that, but It's a little true. Saves me a little bit of trouble because then I know that all of your files are in one specific directory. So I'll be able to open up that zip file, unpack it, say, okay, cool. All the files are here, the assembly's here. I can look through the assembly, see that all those mates are correct, everything is defined or underdefined as it should be, whatever the designation is, then everything will be pretty solid after that. So this is just your way of being able to choose a directory and being able to name that zip file. So this is generally speaking going to be your preferred option. So if I'm looking at the PowerPoint, that is quite literally the last bit of the PowerPoint. So now we get into the fun stuff, which is more advanced assemblies. And I guess I'll just start from scratch with these guys. None of them are really too crazy, but a lot of them are very cool, and I think it'll be much more helpful if I just kind of do the assemblies from scratch as opposed to just showing the assemblies and saying like, hey, here's like the mates that I use. It's like that's not helpful at all. So I'm going to go into the advanced demo first. Um, and the two things that I'm going to open up, kind of like what I said, all this stuff is provided on Canvas right now. So if you do want to follow along with me, totally fine. Just make sure that you have all that stuff open thus far. And I guess kind of before I get into the demos, just like I did before, does anybody have any like just general questions about anything at all that we've gone through?
I had a question quick about the toolbox. When
Yeah.
I'm clicking on the toolbox, nothing's really pulling up. So is there something I'm supposed to like click on after you click on the toolbox to load all this stuff in?
So it should load up automatically, and what I mean by that is that when you hit the design library, you should get you should have two things that are open. One should say Toolbox, and the other should say like SolidWorks content or whatever. But it might not say that the toolbox is actually loaded in. So there should be something on the right-hand side that allows you to add the toolbox and load it in. Hopefully nobody is having issues with that. But it should be there. I would probably recommend, if anything, just maybe reloading SolidWorks, just so that maybe it will take. Zip file, the parts for the homework, and the in class. So there's a bunch of zip files. I guess I should probably explain that. Let me go to Canvas real quick to kind of give you guys the heads up as to which files are which. So, and I think I'll answer your question here in just a sec, Nick, once I kind of give everybody the heads up as to what's going on with the files. Um, so if you're in lectures, so in files, lectures, all the demos should be at the very bottom. So you should see 7-assembly and toolbox, that's the PowerPoint, 7-assembly demo 2, that's going to be the 3 advanced demos that I'm going to do, and then the one that's 7-assembly demo, that one is explicitly just the demo that I just did, I'm pretty sure. In terms of homework and assignments, I haven't uploaded the zip file for the homework yet. I will do it very soon once we get to the in-class portion of tonight. The in-class assignment is uploaded. It should be in the in-class assignments folder labeled IC6-parts. And IC6-guide is that's going to be the template. So that's going to be what you guys should be following with regard to creating this geometry here. I think I just noticed some issue with the center of mass. Just because that center of mass is probably wrong, since the yoke is actually not entirely at the location that it should be. So if you guys don't get that exact center of mass, or if you get something that is kind of close but not identical to it, that's totally fine. What I'm mostly looking for there, if you're looking at the in-class assignment bit, I'm mostly looking for you guys having created the correct coordinate system, and then having like the yoke and somewhere between those two screws. So kind of like what it implies, that yoke should not be able to go beyond the screws that are already there. It should basically hit that screw, and then it doesn't pass either way. And we'll kind of talk a little bit about that in a bit. So Nick, following along with the in-class assignment, having two issues. I can't seem to get the base and yoke to mate. They keep offsetting slightly. So I would recommend in that case is definitely use the align mate bit. Yeah, honestly, a center of mass for like something like that is totally acceptable. So that's fine. Um, I'm not going to be too strict about the center of mass for this one, just because the location of that yoke can be a bit variable. Missed how to make the pin stay in the yoke and not pull out. Okay, so for something like that, you're going to want to consider distance mates. Um, so look in the general mates for distance mates. I'll talk more about some of that stuff later, but I do want to kind of show you guys some of the advanced mates and the mechanical mates. Yes, so unless I missed anything with regard to questions, that should be it. Ross, were you able to get things settled for the toolbox? Is it working now at all? Hopefully.
No, I'm still trying to figure out how to get it to load the screws. And when I click on the toolbox thing, it just pulls up a couple things to the left side, but that's it.
Okay. We might we might be able to play around with it a little bit more later and try to get it all settled. I'll try to look into some stuff. Worst case scenario, if anybody is having any issues with that, I can provide the screws for that example. I'll just find what they are, zip them up, and then not even zip them. I can literally just throw them on canvas or something like that. But hopefully, it doesn't become too big of an issue. So let me go to this more advanced assembly. Is there a way to save parts to your toolbox within the program? So you can save parts. So yeah, that's actually a really good question. If you create certain parts, you can save them in the assembly. I'm not, or rather, save them in the toolbox. I'm not as familiar with doing that. I assume it has to do. Let me see. Hold on. Maybe I got something. Another cool thing that I didn't mention, but I should mention, is that if you have a geometry, if you control, click, and then drag on a specific part, you can duplicate it. So that's something that might be important for some of you guys. I wonder if this works. It doesn't. Okay. God, so many options. In terms of saving, I'm not entirely sure. I would have to look into that. That's a good question. I will make a note of it, and I'll see if I can find a good way of doing it. Nice thing about programs like this is that there's a lot of info online that you can kind of play around with. So, I mean, if one of you guys doesn't Google it before I do, then one of you guys could probably tell me how to do it, because there are certain things that I'm not entirely aware of how to specifically do, that might have just kind of lost how to figure it out. But aside from that, what I'm going to do is I'm going to open up some parts. So I'm going to go to Assembly, Insert Components, and I'm going to go to the Advanced Demo first. So in Advanced Demos, I'm going to open up both the ball and the path. So I'm not going to go through too many of the advanced mates, but there is some pretty cool stuff in here. So you might already see what's going on here, but I have a rubber tube or a rubber hose here, and then I have a ball. And what I want to do, as you might expect, but I want to not only put this ball in this pipe, and I'm actually going to do something first, because I just realized this is fixed. So I'm going to float this and fix that. Not like it matters that much, but it'll help out. Um, I want this ball to travel along the path. So first thing that I'm going to do is I'm going to check out some of the mates that we might have that could possibly be helpful for something like this. So none of these really help out. I mean, tangent could be good, but that's I don't even know if that would work for a surface that we have here. So like if I hit tangent, it might work, but it's still kind of funky. Like it actually does function in a relatively nice manner, but as you can see, it went around a whole other time, and it's still kind of pretty finicky how it's behaving. So I'm actually not going to use that mate. I'm going to hit this back arrow so I can undo it. I'm going to go into my advanced mates, and I'm going to click on this one, a path mate. So probably what you expect, but a path mate allows me to take specifically a point on a geometry and have that travel along the path. And I say a point specifically because it tells us up here it wants the vertex of a component. So I could select several of these things here, but I want to select the dead center of this, which should already be provided. So we'll click on that. And now it knows that's what we want in reference. And now it wants to know what the path is. So I'm going to go over here. I'm going to click that path. And our stuff disappeared, but that's just because it's already inside of the hose now. So I'm going to hit OK. I'm going to close out of this. And now we can see that we have a path mate here. So it's kind of a little bit tricky. We can't actually see it very well. So what I'm going to do first is I'm going to right click on our hose. And I'm going to click this thing. Kind of looks like the yellow part with an eye on it to change the transparency. So now it's a whole lot easier to actually see the ball in the path. And if I click on the ball, I can start to move it around the path, kind of have it follow the guide. If I hit the end of it, it stops. The reason it stops is because this vertex can only go as far as the path extends. So it's not going to go beyond having half of it outside. If I want to, I can basically spin it around the entire thing if it behaves. There we go. Oop. Gets a little bit jittery sometimes, as you can probably see, just because working with things in a 3D setting can sometimes be finicky. But this is just a very general path mate. A lot of these other ones I haven't really created demos for, a lot of the other advanced ones and a couple of the mechanical ones, just because they can be somewhat niche to work with. So symmetric just means that it needs to be, or we need to have something, uh, or rather some face of an object that is between two other faces, such that that original face is going to be symmetrically between those other faces. We have a width one, which is similar to the symmetric, only it just needs to specifically be either maybe between two things, but maybe it's centered, maybe it's free to move back and forth, maybe it's a percent of the distance. We already talked about the path mate. And then linear coupler. Linear coupler is also pretty cool. This would be in a case where maybe you have two things that have very similar motion. Picture two wheels, but maybe one wheel is moving faster than the other, or maybe not even faster, but it has more rotations to it, uh, in reference to the other one. So you can almost, and I wouldn't say it's too much because there is technically a gear mate, but it's almost like a gear ratio. It's kind of similar in that manner. Like I said earlier, definitely watch that video that I posted in the PowerPoint. It's super useful. Guy does a really great job at kind of showing and explaining a lot of those different things that you can do with all of the different mates, all of the advanced and the mechanical ones. Um, I'm going to move on to a different one now. So I'm going to open up another assembly, and let's talk a little bit about some of the mechanical mates. So I'm going to go to Mechanical Demo 1, and there's a handful of stuff here. I'm going to open up a rotary pin, a follower, the base plate, and the cam. There's a cam 2 and there's a cam follower 2 here as well. I don't think I included that. Don't do it. Doesn't work as well as it should. I might show that to you guys later and show how I only kind of succeeded. Uh, but I think this one works a little bit better. So this is going to be like our base plate. Here's our cam. That's going to be our cam follower. And this is going to be the rotary pin. So I'm just going to assemble and mate stuff together from scratch. I think that's kind of the best way to be able to show you guys just the process of going through this stuff. So on face value, the thing that I want to do most is I want to make sure that the majority of my mates are linked up with the base plate. The base plate is going to be like our common mate. We want to make sure that the majority of these things have mates in reference to the base plate as opposed to other parts or other components here. So first things first, I'm actually going to mate the cam and the pin together with the base plate. So I want to make sure that this can slide into the hole that we already have here. So I'm going to go to my mates. I'll hit both the wall or surface of the rotary pin, and I'm going to hit this inner surface of the base plate. And that'll automatically drag it in place. However, as you're probably aware, this can go up and down, and it doesn't really help out that much. So I'm going to make sure that this edge is coincident with that edge there. I could have put the surfaces together like that, and in fact, I'm actually going to do that instead. And actually, I'm just going to show you why I'm doing that instead. So I will do the edges first. If I do those edges first, then, okay, so this does actually rotate. Sometimes you want to play around with these things here because if I had done perhaps maybe a coincident, it might not have moved as properly as it should. So this is fine. Those mates are fine. So we have a coincident mate between those two edges, and we have a concentric mate between the rotary pin and the hole in the base plate. I want to slide my cam onto that rotary pin now. So I'm going to go back to my mates, and just like what you would probably expect, I'm going to make those concentric with one another. So now, yep, it can still move if I click it there. And unfortunately, it can even go through this. So this is where I would probably use something other than a coincident, because if you see this, or if you watch this, if I hit this, and I hit that, if I confirm that mate, okay, it will actually move. Sometimes it doesn't move as proper as it should. And on top of that, because occasionally coincident kind of deems it almost to be like they're glued together. But you'll see here, if I rotate this, it doesn't actually rotate the cam, which I want it to do that. So I'm going to edit that concentric mate that I did. So I'm going to go to the edit feature one more time for the concentric, and I'm going to hit lock rotation. Lock rotation makes it such that now these things move in sync with one another. So if I hit OK with that, now you can see the cam is moving with the pin. So this is pretty good. We're getting there. We have some stuff being assembled slowly. So now I want to make sure that this cam follower is inside of the hole that's given here. So I'll make another concentric mate. And it's the wrong direction, which is fine, so I'll realign it. But now it's not even where it should be. So that's okay, that's fine. I'll hit okay with it, and then I'll move it a bit more. Now here's looking kind of be cool, and I might make this a little bit off-center just to make this kind of a proof of concept. I'm going to use one of our mechanical mates now. So if we go to mechanical, the first option that we see is a cam. So this requires two things. It requires it doesn't have to be a smooth path, but your assembly is going to like you a whole lot more if it is a smooth path. So I'll click the path of the cam, and I'm also going to click the face of what is going to follow this surface. And it did something that, or rather, I did something that I didn't want it to do, but that's okay. It's kind of off-center because now it can rotate in this direction, despite it, and do that, unfortunately. So I want to make sure that this kind of flat surface is faced against or faced rather towards the rest of our plate. So I'm going to create a parallel mate between those two. And now let's actually just play with it a little bit. So certain things are still underdefined, but that's okay. I want to make sure that you guys kind of get an idea of what's going on here. So now you can see it's almost like those two faces are glued together, but they can slide. So it's going to be creating, or rather it's turning some sort of rotational motion into translational motion. Some of you guys may have discussed that in maybe some classes, or you already might have a pretty good understanding of that. That's really all it's doing here. It's pretty neat. Sometimes, obviously, if you go too fast, the graphics can't really keep up with it, so try to be gentle with it. Also, in retrospect, I chose a really stupid material for this cam follower. I wanted it to just be distinct, but it kind of clicks right through it, which is really dumb. And this cam is also free to move, so if you want to just grab the cam or click on the cam surface and move it, that works as well. Now, what about what we saw earlier, or even maybe if I can get it to work. So it might not do it, which is okay. Or better yet, let me try something like this. Sometimes if you push or pull, yeah, there you go. That's not a good sign, because not only is there major interference, but that's nowhere near where this should be. So I want to actually limit the distance that this cam follower is allowed to move, if I can get it back. There we go. Sometimes you just gotta pull it a little bit. So I'm going to make an assumption as to where the minimum distance between these two faces should be. So if I click on these two surfaces, it's telling me that it has a normal distance of 3.01. So it's about 3. If I were to maybe give it a minimum distance, I might give it a little bit more leeway in the event that weird things happen. But we'll kind of play that by ear. And then I'm also going to find out what the maximum distance between the two is. And keep in mind, this is just a very rough approximation. So this says 34, I would probably go with 35. So I'm going to go back to mate, and I'm going to say that these two faces here, so right now it's already saying, or assuming that I want it to be aligned with one another, which I don't, or at least not entirely. I'm going to go to, why are you overdefined? Oh, because I haven't selected the correct thing yet. I'm going to go to the limit distance in the advanced mates. When I click on this, kind of just like we saw before, it's showing me the two different distances that I can adjust. So just for the sake of ease and just to be sure, I'm going to select it to be 35. And this one I'm going to say, so we said that it was about 3, or it showed that it was around 3. I'm just going to put like 2.75, 2 3/4 of a millimeter. Then when I hit OK, there should be really no feasible way that I can just pull this over. You can see I'm kind of trying to move it, and it's really not doing a whole lot. You can see it's kind of moving a little bit, but it's not really moving when I'm trying to jerk it past where it should go. Things are still moderately underdefined, but by and large, that's really okay. I'm not going to be too rigid with things being underdefined for the sake of uh, these problems here. I mean, what I might do here is I might say, hey, well, this is, like, I mean, obviously, if you tilt this plate, it could end up falling out, but I don't really want, or rather, here, let me do it like this. Choose, say, like the minimum distance, or maximum, rather. These two, I can probably define these as well and say, hey, it can be about 47 at its maximum, and I want it to be 0 at its minimum. So I would probably create a mate there as well to say, okay, well, I want it to have a max of about 47, but a minimum of 0. And maybe that'll alleviate it. So we now know that the follower is fully defined. This, unfortunately, is not totally defined, and that's likely because this can still rotate fairly freely. If you want, I wouldn't say it's very necessary, but if you want, you could put, say, an angle mate on something like this and say, well, I'm just going to pick something that's stationary and something that is not stationary, and I'll say, hey, oh, I don't. Okay, I guess you don't like that face for it. I'll select an edge instead if I can. Come on. Maybe you and you? I know there's a way to create kind of like mates that are like that. So for two like these, I can just say, well, it can be a minimum distance of 0 and a maximum distance of 360. This isn't really entirely necessary, though. I mean, as you can see now, actually it fulfilled things for both. So now it's totally defined because certain things were related to one another. So now we actually have a fully defined assembly. I'm not going to be very rigid with regard to fully defining assemblies, just because I know that sometimes it can be a little bit tricky, just like how it was a little bit tricky with regard to in the beginning when I was asking you guys to fully define your parts. I think I have one more. Yes, I do have one more. Okay. Last one, I promise. So we'll go to assembly, and now we're going to do the mechanical demo 2. And I'm going to open up the plate, the pin, and the hinge. Failed to open file. That's pretty awesome. I don't know why that is. Epic. Pardon? I would assume. Okay, well, I guess I'll only do part of this one. I was going to demonstrate both hinge and slot, but I guess as it stands right now, Solidworks only wants me to do one of those two things. So just open up the pin and the hinge and make sure that, I guess in this case, the pin is fixed and the hinge is floating. So this one's going to be a little bit tricky, and that's just because we need to make sure that certain things are selected appropriately. So what I'm actually going to do, I'm going to hit this I at the top, and more specifically the little arrow next to it. And on the right-hand side, kind of second from the top, you should see something that says View Temporary Axes. Click on that, and what you'll see is you'll actually see not ones that you created, but ones that are a part of, rather naturally a part of this geometry already. So any sort of curved surface is naturally going to have an axis of rotation about it. So I'm going to go back into my mates, and this one actually has a lot of things that we kind of need to consider. So when I hit hinge, Now there's two boxes that we can play with. The first box, and I'll try to break it down in a reasonable way, and the names do kind of give things away a little bit, but I'll explain it regardless. Concentric selections is referring to now I already forgot. I believe that's referring to the axes themselves. So if I select this axis and I select this axis, then it seems to be happy. Coincident selections are going to be things that, like we said before, should be coincident to each other. So these could be, I think it could be a curve, yeah, or rather an edge. Okay, it doesn't really like that one that much. So I would opt for faces for the selections themselves. So I'll say that this top face should be coincident with that top face. And now we can see that it lines up kind of like how we would expect it to. You can even specify angle limits, how much it can move. I think this needs to be relative to something specific, so perhaps relative to maybe this face or not. Selected entities are not valid. Please choose valid entities to meet. Click undo or close. Cool, so I'm actually not going to specify. Oh my god, you're killing me here. Okay, there we go. So I just had to make sure that it wasn't specifying an angle there. So just to kind of go through one more time the specifics of the hinge mate, concentric selections has to deal primarily with axes. So you essentially want those axes to be on top of one another, coaxial. Similarly, for the coincident selections, those should be kind of where certain things are going to align, specifically like faces, more specifically like flat faces. So here we're totally all good. And you'll see, if I grab this, it rotates quite nicely around that, what would you call it? Common axis. Let me see if I can kind of do what I wanted to do, which was I had a base plate, and unfortunately I'll try to re-upload this so you guys can take a look at it as well, because I guess Solidworks just really didn't like the base plate that I made, for God knows what reason. I have a few thoughts, but who the heck knows. Yeah, whatever, technical support, as if. So this is a distance of 10, and this is a diameter of 20. Okay, cool. So I'm just going to create a very quick and dirty base plate here. So extrude, you, 10 millimeters, sure. Going to make sure that this is properly in millimeters. I want to sketch, and specifically for this one I was using a 3-point arc slot. So what this is going to do, this is actually pretty cool. It's kind of similar to the 3-point arc, only I designate a specific path and then the specific radius to it, and then I go out how far I need it to be. I'm going to just smart dimension this. I said that this should be 10 diameter, which means a radius of 20. It's kind of big, but that should be fine. I'm going to cut out this selection here. And then I am going to save over this piece of garbage because for whatever reason it's just angry at me. Already open? What? Whatever. Fine. I'll make it plate 2. And then we can put this plate into our assembly. Like I said, I'll see if I can re-upload at least part of this because God only knows why it decided to be a massive pain. Okay. You, I want to float. You, I want to be fixed. That's too big. Am I really that dumb? Did I mess that up? I think so. Okay, cool. I might have flipped those things. Awesome. Yep, I did. There we go. Hopefully I'm not losing my mind too bad here, because God only knows it feels like it. That... Maybe. Anyway, I'm going to at least align certain things properly. So I want this hinge to be underneath my geometry there. So let's put that there and that there, and we can mate those two things together. And that looks like it's proper. And then I also want to create a slot mate. So this will allow me to select the slot, and also I believe it's just the surface. Okay, yeah, that's good. Okay, cool, now it's looking a whole lot better. And it's a free constraint, so that just means that technically this is going to move along the slot, as you can see here. It's moving relatively fine. Okay, don't think I'm going totally crazy, that looks alright. And in addition to that, this part can also move, and you can see sometimes it might move more so than what we want it to. So this is a fairly open part that we don't really, I guess we generally wouldn't want something like this, but as I said, it's more of a proof of concept, showing you how to really use those hinge features or a slot feature in a case like this. Uh, Honestly, I really like having those temporary axes up, just because it gives you a good representation of where certain certain things are, certain axis of rotations are. So it can be good reference or good reference points in the event that you're ever trying to do geometry like this. I was going to make this more complicated, but this is a fairly good proof of concept as it stands right now. I can't move this because the bottom surface of this pin head is basically fixed against this surface, so it's not glued to the surface. It can move fairly freely, but I can't pull it down. I can't remove this part. That is by and large all I was going to talk about today. I already saw that a couple of you, or I noticed that a couple of you have already started on the in-class assignment. If some of you haven't already, with me blabbing about these more kind of advanced features to work with. Really, the primary reason that I'm discussing these features here is just because they will be useful sometimes. I guess one way that you can kind of put it is that your general feature or your general mates or standard mates you're going to use very frequently. They're going to be the gold standard way that you're going to start at some mess of parts and create some sort of cohesive assembly out of it. Advanced mates is when you might need to do something relatively specific that generally speaking cannot be accomplished, or just without a doubt cannot be accomplished with a standard mate. So things like very limited angles, limited distances, linear couplers, having things specifically in a very central location. Maybe a part needs to move along a very specific path as opposed to just being totally free reign. Mechanical mates you will use sometimes. We're not always going to have things that have slots or cams or hinges or gears in them, or rack and pinions. Those are more niche assemblies that you will use at some point. I guarantee you there will be instances where you'll use it, whether it be sometime when we're going through assemblies for the next couple of weeks, or sometime beyond when you need to work on other projects like senior design related stuff or anything of the sort. So these are important things that you will have to have at least a very baseline understanding of. Honestly speaking, kind of the reason why I gave that video. I'm not going to lie to you guys, with regard to the advanced mates and the mechanical mates, I'm 36 to 48 hours ago, I was right where a lot of you guys probably are right now. I was like, I don't know some of the specifics on how to use or when to use some of these things. Even some of the advanced mates currently are a little bit vague to me, because at least if you understand what a cam is, you have an idea of what a cam mechanical mate is supposed to do. Something that is following a path that's giving rotational motion and creating translational motion. Something that literally just says width or symmetric. K? The heck does that mean? So some of these things might require either asking questions or looking things up, seeing how people generally use these. So that's the main reason why I added that video in the lecture or in the PowerPoint. So to kind of put a bow on all this stuff, that's really all I had with regard to this topic here, or with regard to kind of going through some more advanced mates, kind of how to start off with assemblies in general, how I want you guys to be saving the files. Um, any questions about anything that we've gone over today so far? If I haven't already covered it, or if it's something that I went too fast, or something that any one of you guys have missed.
Can you cover that minimum distance, maximum distance thing? Because I'm trying to work on a classroom assignment to get it to move between the two screws, but I just can't get it to sit between them right.
Sure, yes, and I figured that's definitely one of the ones that's going to be kind of maybe not on the trickier side, but it will be used quite often. So what I'm actually going to do, I'm actually going to suppress the hinge for the time being because we don't really need it. This should actually be a sufficient enough example. So, and actually on top of that, I'm going to suppress the coincident as well. So, no, not that. Suppress. Go away. Thank you. So right now it's still in the slot, but it can move freely, and technically speaking, I mean, even if I move it out of the slot, it's still going to follow the path. You can see kind of in the shadow there, but it can move right through this plate, which is something that we totally don't want it to do. So I'm going to move it down here, and I want to make sure that, let's even do it like this. No, that's fine. I want to make sure that this surface and this surface can touch. They can't go past each other, but then this isn't going to fall out or anything like that. I don't want this hinge pin falling below a certain distance, or else it's just going to fall right out of the plate. So what I'm going to do is I'm going to go to my mates, and I'm going to go to the limit distance mate. So limit distance is a great way, kind of like what I said before, and this maybe I'm just using a really bad example for anybody who hasn't really taken much calculus or differential equations or anything like that, but these are kind of like your boundary conditions. Think of it as where I want this pin to stop on both ends. So I want it to only go up maybe such and such far and only be pulled out of the plate such and such distance. So it already has limit distance selected. I'm going to select the two things that I want to be able to be directly in contact if they can be, but also they could move a bit more as well. So I'm going to say that the minimum distance can be 0, but the maximum distance could say be, let's do like 4 millimeters. It can only move out just a little bit. So when I hit enter on that, and then I hit OK. If I exit out of this now, so what you'll see is that there's a little gap there. And in fact, what I'm going to do, I'm going to go normal to this so you can kind of see this a little bit better. If I try pulling up on this, it will not go past. It will not go past that plate. It is bound, I guess surfaces are kind of bound together almost. But it can be pulled out just slightly. And if I actually look, if I click here, and if I click there, we can see in the bottom it says a normal distance of 4 millimeters. So it's only allowed to go down away from those reference points. There's only allowed to have a gap of that much between the two. but it can be butted up right against it for something like that. So, and I know that this is probably more so in reference to the guide and yoke that a lot of you guys are currently working on right now. I would recommend playing around with perhaps, let me actually take a look at it. As soon as I can find the darn thing. I would probably recommend playing around with either one limit distance that you kind of play around with the numbers a little bit just to kind of get a better understanding, or use two limits to kind of better understand, two limit distances to kind of better understand how things interact. Now keep in mind, if you do two limit distances from different locations, things might get a little bit hairy if those distances are different. I think what I would primarily recommend is try to do a limit distance between the two things that it's supposed to be between, or rather between the thing that can move and the thing that can't, and then play around with the numbers appropriately, such that the left-hand side, I guess you could say, or rather the front of the yoke is going to hit one screw, and the back of the yoke is at best going to hit the other screw if you pull it all the way over there. And just, I mean, I know that most everybody is here right now. I'm not going to be too crazy or too anal about the center of mass. By and large, that number is not going to move around too much for the yoke because it's confined to a very small region. I mean, it's confined to a 77 millimeter region. That's almost 8 centimeters, which is not very big, if my understanding serves correct. For something like the homework, I do want you guys to at least be relatively specific about the homework. And in fact, I just reminded myself I'm going to upload those parts right now, or the zip file for those parts right now, because I forgot like 4 times already, it seems. So just kind of be cognizant that your center of mass might not be exactly what it is. That's more so my fault with regard to the in-class assignment. For the homework, it should be a whole lot more rigid in that manner. Let's do homework 6.
Oh, another quick question about the class assignment. The
Yes.
pin in the top, do you want it to be free moving up to a distance of 40 millimeters like you marked on the page? Or do you just want it to be fixed at that 40 millimeter distance?
It should be fixed. Good question.
Okay.
If it's free to move, I'll put something like that in the notes, kind of similar to how I did for that drawing. I'm pretty sure I did. I'm not actually looking at it right now. Let me actually pull it up. So, yes, so the hole in the adjusting pin should be fixed normal to the long groove. So when I say normal, it means that hole should be pointed directly to the side. But given that the yoke is confined between those two screws, I'm really just saying that it can hit a screw on one side, it can hit a screw on the other side, but it can't go past that screw. It's confined to that region, and it's only necessary on one side of the, or rather, the screws are only on one side, so there's really a necessity to only add something like that on that side. Library is invalid. What did you click to get that notice? Because that's... Oh, when you're trying to pack and go? Really? Haha, what the heck does that mean? Document Manager Library is invalid. Well, time to Google. Okay, before you do that, which that's not a bad idea, but before you do that, try this. So there's that link, and there's also something, better yet, I can just copy and paste it. Someone recommended that. So opening up the command window, running things as an administrator, and then typing that into your command window. I if that works as a fix, then I would go with that as opposed to just repairing the installation, because that's a it's pain, as you might imagine, and a lengthy process as well. Then I believe they mention in there, yeah, so close and reopen after doing that. Obviously, I would probably recommend not having SolidWorks open at the time when that's going on. And hopefully we don't break literally everything by doing that. And just so it's on record for the recording, since I stopped recording for a moment, but order of operations with regard to creating your assembly and parts and zip file is use the pack and go as a folder as opposed to a zip file. Save the assembly into the folder that you use the pack and go for. Make sure that your toolbox selection is included so that all the toolbox parts are going to be inside of that folder along with all the parts that you used. Save your assembly and make sure that that assembly is saved inside of that folder, and then zip that folder up and submit that via Canvas. That should make sure that everything is appropriately all in one place and not scattered about. Hopefully. God only knows if that will end up being the end all be all, but I got my fingers crossed that will work sufficiently enough. Hopefully everybody is not having other weird pop-up issues or SolidWorks yelling and screaming at them right now, or else I'd be a little bit upsetty. Yeah, so basically what I'm saying, take a screenshot of it if you could. Or is it the same thing that you were getting there, Nathan? That, like, SolidWorks Document Manager library. I just want to make sure that if there is a common error or common errors, we can hopefully, maybe, possibly, potentially get them sorted in an appropriate manner. If you guys want, I can kind of draft up like a little guideline as to like appropriately saving your assemblies, because for God knows what reason it's being a bit of a pain in the nicest way possible. Yeah, I think I'll do that. Just make like a little PDF file for you guys to be saving things appropriately that can be referenced. That annoys me. Oh well. Workarounds. So if somebody wants to, I should actually check those files to see if the assembly is in it as well. But maybe it'll work. Oh, sick. Okay, so it did include all the things for me. If one of you guys wants to do a zip file with those 3 things selected, please do, and maybe confirm if that works or not. Fingers crossed. 14WN, referring to the hex bolt. Let me double check. I believe that is the case. I can't even remember the specific bolt that was used, so let me look at that. So it says B18232M formed hex bolt M5 wait, 14. I would, yeah, I would believe that that would probably be the thread, but let me just double check here. So we said hex, and it is a formed. Yeah, it's going to be the thread, the length of the thread. A good way that you can check always is at the bottom, it will show you a configuration name, and that will generally speaking show you the like all the different names, or rather like what the name of that screw is supposed to be. That'll kind of tell you all the details that you would need. I don't know if this one actually says that it was a washer screw at all. What's the difference between these? Okay, you'll actually see, and I probably should have explained this a little bit better, but under finish, the two selections that we have are washer face and chamfer. So the 14 is referring to the thread length. I mean, along with just the general length of the screw, but that's this 14. And the CN, or rather the C, is referring to chamfer finish or a washer finish, WN, that's there. So I didn't do that on purpose, but hopefully nobody is playing with these settings really too much. I'm I mean, I guess I should say, first of all, since I wasn't really aware of that in terms of the configuration name right off the cuff, I'm not going to pull a gotcha on any of you guys with regard to something like that. I will be sure to mention if there is something like that, look at the configuration name if that is a point of interest. Otherwise, I won't make a big deal out of it if it's one or the other, so long as the general features regarding like the size and length, perhaps the thread length as well, are there. Uh, I'll be happy.
So I've set up the coordinate system and everything, but the center of mass is like all over the place
Is this for the yoke?
for the in-class assignment.
Okay, so yeah, so the guide and the yoke. Is it really changing that much? That's weird.
Well, so originally it seemed to be defining it by the origin, measurement from the origin, regardless of the fact that I had a coordinate system already established, or a new one. So I just made the point that's supposed to be the point of the new point of origin for the new coordinate system, coincident with the origin,
So
and it's still wrong.
okay. So the one thing that I would say to that is it, and maybe you already did this, but we do have to be able to show or specify that new coordinate system. So in the mass properties menu, it will say report coordinate values relative to blank, or it just will do default, which is in reference to the global coordinate system. So you want to click your global coordinate system 1 or whichever it is. You can recalculate that or hit recalculate if certain things are being adjusted while you're working with it. So like if I'm moving this shaft a little bit more, it doesn't recognize that, or rather, it does recognize that I've changed things. So I'd have to hit recalculate. But given the fact that the coordinate system is in the same general location, the value I would assume shouldn't be really too different. So this one is about 2 negative a quarter. Something like that would be 2 negative 1 and a quarter. So it's really just shifting a bit more of that. Oh, well, that's because it's the guide. So that actually also matters. I believe. Okay, I forgot about that. So certain things, if you're in your mass properties menu, it will define different parts. So you can find the center of mass of just a specific part. So you want to make sure that this top thing in the box up here is going to be your assembly as opposed to just a specific part. That might be why it was happening. Because if you're clicking on different parts within your SolidWorks assembly, or perhaps just a specific part, and then you click on a different part and recalculate, it might throw the center of mass for one part somewhere else as you shift it to a different part. That might have been what happened. So like right now, it's just this guy, but if I move this over, it's only a little bit different, but it's fairly similar.
Okay.
Was that perhaps maybe the issue?
Well, I didn't realize that it was reporting relative to
Yeah,
default.
yeah, I forgot about that as well, that you can actually, since you are dealing with multiple parts, there is the potential for it to say, hey, I'm only going to report the center of mass for this specific part right here, as opposed to, I mean, X, Y, and Z, whatever those parts might be. So that's probably what was happening, potentially. And I'll make sure to put out an announcement, definitely, or like hopefully tonight, just saying like, hey, if anybody is still having issues saving files, we can try to find a workaround. Just because I know out of everything, that seems to be the crutch that SolidWorks is willing to die on in this situation. I can't quite hear you if you're talking. See if you can disconnect and then reconnect. Maybe that'll work. If someone is talking.
So for the in-class submission, you want us to move the piece along the slot as close to the center of mass as possible?
It doesn't. So yeah, it's kind of my bad. I should have been maybe a little bit more specific about that because I forgot that the center of mass is really going to change kind of depending upon location. In fact, now I should actually double check to see if I grab the center of mass correctly. Just make sure that the yoke is at bare minimum confined between those two locations. And so long as it is confined between those two locations, if the center of mass is approximately what you see on the diagram, that will be that'll be good enough. Let me, like I said, let me double check that right now to see if it is indeed where it should be. Okay, yeah, it is. Because presumably, if I do that, and then recalculate, only the z-axis is going to change, yes. And that makes sense because you're only moving the yoke and technically the adjusting pin, but the only thing that's really being moved is just the yoke and adjusting pin along the z-axis. So technically speaking, I mean, heck, so long as it's somewhere between negative 44.5 and what the heck was that one again? Negative 55.5. I won't be too unhappy. I mean, if things are a little bit different with respect to the X and the Y, that might be a bit more cause for concern. Save. Okay, hopefully that's at least some information with regard to the message that I just sent out for anybody who might be having any issues. Hopefully this doesn't become too big of an issue down the line, because that would massively suck. But we will play things by ear. As we have for pretty much the entire semester anyway.